Dr. H, this is my new iPad app. I've had it for a couple of years, but taking your class has forced me to learn how to use it this past week. I think I've learned how to use it well enough to actually create something useful for my classroom. I'm going to use it this coming week, actually, in a unit that I've been working on with my students on surface area and volume. The app is called Doceri. It allows you to create images, presentations, annotations on existing presentations, everything with audio, save it, turn it into videos, post them on YouTube, Facebook, and then share them via your computer onto any kind of interactive smart board through a projection device. The other cool thing about it is with the existing software that comes with it, you can take control of your interactive whiteboard, and as you're going around through the classroom, you can make annotations on whatever is on your smart board, save those as well, turn them into a video. You can do this. You don't have to be at your computer. You can be away from your computer. You don't have to be attached to your smart board. All these things. It's a really cool app. I'm still learning how to use it. This has taken me an incredible amount of time. I'm a slow learner, I guess. Anyway, this video is about using this app for mathematical practices with a problem. It's the third problem in our unit on surface area and volume. So the problem says, what volume of concrete is required to build this footbridge? And as you can see, it's a strange looking shape. So in order to guide students, they've already worked with surface area and volume of regular prisms and cylinders. However, this task presents a non-routine problem due to the shape of the structure. So to get them started, I've given them some prompts to think about in relationship to this problem. I want them to think about the shape of it. It's kind of strange. The dimensions, in other words, the lengths that are given, the background information that they already have, or some more background information that they may need. They may not have everything that they need. So, in terms of the shape, they obviously see it's circular and cylinder, and make the connection from two-dimensional to three-dimensional. But in order to help them, I'm going to superimpose these two circles and show the radius of the smaller one and the larger one without, of course, labeling or telling them. I just want to highlight where those are located on the inner and outer edge. And hopefully they can make some connection that way. The next thing that I want them to notice are the dimensions. So the problem is labeled with 2 meters, 4 meters, and 2 meters. The problem is students need to ask themselves, what are these lengths? How are they related? What part will they play in the problem-solving process? What are they supposed to do with these numbers? What do they go with? What parts are they labeling? Students are used to finding volume with prisms by multiplying length times width times height. They forget that when they get to a cylinder, there's no longer a width. It's now the circumference, and so they have a really hard time wrapping their head around that. So not only do they have that issue here, but they've got the issue of a cylinder that's cut in half and a cylinder that has a smaller cylinder cut out of it. So they have a lot here to think about. So I'm trying to guide them into asking pertinent questions and thinking about this in some ways that will help them in their thinking process. So the next thing I want them to think about is what background information they have or already or they already have, or they may need. So, for example, they hopefully already understand that it's a three-dimensional figure and have made the connection and realize that it is indeed half a cylinder. So, what does that tell us that we need to know in order to solve this problem? It's going to affect the solution strategy. Hopefully they will realize that. Another strategy that would be useful to model for them in this situation is to draw it from another perspective. This way they can see it from another angle. So I'd like to draw it for them sideways and label it, of course. And then it's not the same view that they've had in the problem, but in this particular drawing, I've got the radius of the outer and the inner circles labeled, and then I've got the height labeled, but I'm not telling them that's the height. But hopefully the way I have laid the cylinder on its side and extended it as a complete cylinder instead of half of a cylinder, they can make that connection that that is indeed the height. I've also cut the cylinder in half and shown them how to take that half away. So maybe they'll make that connection, because I'm not giving them any information. I am not telling them where the radius is. I'm not telling them the diameter. I'm not telling them where the height is. I'm only telling them these numbers. I am not telling them what they are or where they go. But I'm trying to give them guiding questions that will lead them to make these connections themselves. So that's another strategy. The other strategy that I would suggest to them would be to perhaps think of it in terms of two separate cylinders. So they might want to take them apart and make it a simple problem. And that is another strategy in terms of the Common Core mathematical practices, is make it a simpler problem. They could model this by using technology such as GeoGebra or SketchUp or something else. They could even use graph paper for that matter. And by taking it and viewing it as two separate smaller problems. However, will they have will they realize that it's the same problem, or are they going to think about it as two different problems? Are they going to realize the relationship between them? So need to ask those pertinent questions so that they will make that connection. As they're doing that, I will ask them if they have any other questions before I lead them to the final question, the big question. How do we use what we already know? So what information do they already have that will help them? What relationships exist between these shapes? In other words, between the circle, the cylinder, and what they know about area, circumference, and volume. That is, if they bring up circumference. I'm not going to tell them. And how this whole process that I've done with them, hopefully this modeling and guiding them through the mathematical reasoning required in order to engage in this problem-solving process, will help them so that they can already begin. And the whole purpose of this video is to get them started on their task, which would be devise a plan, ask themselves what tools they need to get started, and what questions do they still have, or if any, they might have later. And that concludes my video on how to use the Doceri app for iPads in the classroom. Thank you.